In the next lesson, we're going to be talking about interpreting and sketching graphs. So this is similar to what I showed you the other day, where I give you a scenario and you have to be able to graph what that scenario is. So here you're given a graph and we're supposed to kind of describe what's going on. Okay, a couple things you should know. This is your dependent variable. This is your output. Time is an independent variable because we can't stop time. Okay, that's your input. So what's happening here? Well, for example, what's happening right there? This says that time is 0, the depth is 0. So you can picture the scuba diver sitting at the surface of the water. Okay, then as time goes on, the diver is going to go down. And eventually, right here, it's going to return back to the surface. How many minutes did this dive last? I think that's 30 minutes. Okay, so from start to finish, the time elapsed is 30 minutes. At what times did the diver stop her descent? So this line here indicates we're getting deeper. Okay, when we get to this place right here, the diver is not getting deeper. For some reason, the depth is not changing. From 4 minutes to 8 minutes, the depth is not changing. Okay, so we're going to say from 4 to 8 minutes. And then again, up here, that's from 9 to 11 minutes. Okay, maybe the diver saw a shark and froze and didn't want to move at all. Okay, what was the greatest depth the diver reached? Okay, this is depth. This is the biggest number we've got. So the deepest this diver got was 20 meters. For how many minutes was the diver at that depth? Well, what do we say here? Well, that's 10 to 14. I made a mistake here. So how many minutes? 20 meters for, looks like 4 minutes, from 10 to 14. Okay, and what do the two horizontal lines in the graph means? That means we're not getting deeper at those points. Okay, horizontal means like that. Okay, so we'll say no change in depth. All right, note straight lines are used in graphs when the change is constant. Curves are used when the change in the independent and dependent variables is not constant, like acceleration. So what this means is, anytime you see a straight line, it's a consistent or a constant change. So the depth, this person is going deeper at a steady rate. Okay, that means no change in speed. The depth is constant. Okay, we'll keep that in mind. Straight lines are important. Okay, let's hang on a second here. I have a little trouble with this graph. Okay, let's check out the next one. Interpreting this graph. So here you have one. This doesn't have lines. It just has a bunch of individual dots. It says each point on the graph represents a bag of popping corn. You can see why we wouldn't connect it. If this is bag B and this is bag A, it makes no sense to connect the two because there's nothing in between those two. Which bag is the most expensive? Okay, this is cost, this is dependent variable. Looks like the most expensive one is C, and it is $7. What bag has the least mass? That means the least weight. Okay, looks like B, and what would that be? Looks like approximately 500 grams. Which bags have the same mass? Okay, I think if you're looking at mass, you're looking at D and E. And what is that mass? I think that's 1,800 grams. Which bags cost the same? It looks like A and E both cost $4. I want to know what kind of theater this was where the popcorn only cost $4, because that's not a theater I've ever been to. Which of bags C or D has a better value for the money? So look at those two. Which one is a better value? Hopefully you said D. Why is it a better value? More weight for less money. Okay, you can see D is heavier and it's also less expensive. Okay, next one. So here we've got a graph and we're supposed to describe the journey. All right, and it says for each segment, because you can see each of these lines represents something different. Okay, so first, what is happening when I go from O to A? What does this line represent? Okay, well, what is this graph about? This graph is saying the distance from Winnipeg as time goes on. Okay, so this is going to mean the distance from Winnipeg. This means I'm in Winnipeg. The distance is 0 when time is 0. After 1 hour, it looks like I've traveled about 65 kilometers. Okay, I should also say that it was a constant rate. That means my speed was consistent because the distance I was traveling went up at a constant amount. Okay, what do you think is happening from A to B? All right, looks like whatever we're driving here is stopped. Stop for 15 minutes. Maybe it's a bathroom break. Okay, then from B to C, what's happening from B to C? Well, I travel, looks like another 65 kilometers. But this time I do it a little bit faster. I do it in 45 minutes. Again, it's constant rate. Okay, what's happening from C to D? Well, from 2 hours to 4 hours, I'm not traveling any distance. So what does that indicate? 2 hour stop. Maybe they were visiting, maybe they stopped to eat. Who knows? Okay, then D to E. This is a trip back home. What's happening? The 130 kilometers that I have to travel, this distance, it took 2 hours. Okay, so travel 130 kilometers back to Winnipeg in 2 hours. Okay, for sure, I'm going to get you to do that on a test. I'll give you a scenario like that and you have to describe it. Okay, on the other hand, here you're given the scenario and you have to graph it. So it's exactly the opposite of the previous question. Okay, lots of clues in the question. Let's read it. So sketch a graph. So it doesn't have to be super accurate. Do the best you can. Use speed as a function of time. This is really important. So speed depends on time. This tells you that the dependent variable is speed and the independent variable is time. So I'm going to put time down here and I'm going to put speed down here. Now, typically, you don't get any numbers. You're not told, what is the time and what is the speed. So I don't have to put numbers down there. This is an estimate. Okay, so it says the car is traveling at a constant speed. So I don't know what the speed is, but let's pick this. So we're traveling at a constant speed. The speed is not changing. Okay, then the car speeds up to pass a car. So it goes faster for a little bit. It's speeding up. and then it maintains the new speed. So now I'm going faster, but again at a constant speed. Okay, then what happens? The driver is then pulled over and given a ticket. Pulled over. So should I go like this and stop instantly? Hope that doesn't make sense. No matter how fast I stop, time will pass. So I can't stop instantly. It will take some time. You know, if I think I brake slow, maybe it would look like that. It doesn't say how fast I brake, but the reality is I'm stopping. All right, here I'm going to be stopped because I'm getting a ticket. And then it says then continues the journey at a constant legal speed. So accelerates, and we'll assume this was the legal speed here. For a while it goes like that. Okay? Why don't you pause the video for a second and see if you can do this one yourself. Okay, distance from home as a function of time. So again, time is independent, and distance from home. So distance goes here, and time goes down here. What's the scenario? The girl leaves home for school. So the distance from home is going to increase, but then gets halfway. So I guess the total distance would be like, if this is half, total distance is going to be up there, something like that. But realizes that she forgot her cell phone. Panic sets in, and this might be the only time where you instantly get home. No, kidding, not instantly, but maybe quicker. Maybe we're going to sprint home because we want to get home fast. Okay, so you can see that's a little bit steeper than the first line. Maybe it's not. Maybe it would be the same. Maybe you thought, no, this person was traveling at the speed limit and it stays the same. Doesn't tell us. Okay, so returns home, picks up the cell phone, let's say stayed home for a second to get it, and then travels the rest of the way to school. So this would be at a constant rate, and it should be twice as far. So if this was how far the first time was, this would be twice as far. Okay, and here we've arrived at school. Okay, so you can ignore this. Let's go to exercise 27. That would be your homework for today.